Hi class, welcome again to another session on biomaterials. So today we are going to discuss vascular grafts. So vascular implants have been used for a very long time for a wide range of applications, right from anastomosis of after removal of a vessel, or for as a vessel patch for aneurystic artery, to ease the pressure of the artery that has aneurysm in it. So one of the major prerequisites for a biomaterial to be used as a vascular graft is obviously hemocompatibility, because it's in close contact with the blood. So when we compare the layers of blood vessels, you have the tunica media, tunica intima, and tunica adventitia. So tunica intima is the innermost layer of your blood vessel, and tunica adventitia is the outermost layer of your blood vessels, right? When you compare these two levels, mainly due to the presence of mucopolysaccharides such as chondroitin sulfate and heparin sulfate, the innermost layer, that is the tunica intima, is negatively charged when compared to tunica adventitia. So this is an important factor to take into consideration when you are using a biomaterial to develop an artificial blood vessel, right? So the efforts to improve blood compatibility of synthetic material include negatively charged surfaces coated with biological materials such as heparin and albumin to improve the blood compatibility of the material, then inert surfaces and solution perfused surfaces. So these are the four types of surfaces which are used to improve the blood compatibility of a synthetic material. Now, polymers used in manufacturing vascular grafts are often treated with heparin, mainly to prevent blood coagulation, right? So when you are treating the surface of the material with heparin, chances of heparin leaching into the bloodstream from the polymer surface is an issue, right? And this effect can be minimized by cross-linking. Coating polymer surfaces with albumin also improves the short-term thrombogenic properties. So albumin, there have been studies or there have been implants where albumin has been coated in vascular grafts made up of dracan, and this has displayed decreased affinity towards platelets, therefore decreased chances of blood coagulation. Vascular grafts with heparin and albumin conjugate have also resulted in the reduction of fibrin formation and platelet aggression. So albumin pre-absorbed on the surfaces reduces platelet adhesion, and heparin prevents thrombus formation. So these two, when used in conjugation with each other, definitely improves the blood compatibility of the vascular graft. Hydrogel such as polyhydroxyethyl methacrylate has also been used, and this has also been known to be a good hemocompatible material. So flexible polymeric devices are also coated with carbon in order to improve their hemocompatibility. A negative charge in a vascular graft is obtained by copolymerization or grafting type of polymerization. We saw different types of polymeric chain. So a grafted polymeric chain is actually more efficient in producing a negative charge surface. So you have basically two types of blood vessels, artificial blood vessels, either synthetic or biological. So biological is not artificial per se. It is just one blood vessel, the blood vessel taken from one location of the body and used for grafting in another location. Right, so let us discuss the synthetic one first, and then we shall move on to the biological one. So the overall potency and long-term biological effects of a vascular graft is influenced by the porosity of the material. Right, high porosity facilitates transmural ingrowth of vascularized connective tissue, so that makes the whole graft really strong, and it helps in amalgamation of the graft with the artery, and it has also aided in development of continuous pseudo-intimal lining. So pseudo-intimal lining, it's a lining next to the tunica intima, and if that is developed properly, then the graft actually anastomoses with the organ very efficiently. So synthetic graft materials used for replacing larger arteries, that is arteries within the diameter of 12 to 30 millimeters, and medium arteries that lie in the diameter of 5 to 11 millimeters, And synthetic vascular grafts have been used for these purposes. So larger vessels are usually made up of Draken fabric, and medium diameter vessels are made up of PTFE, which is polytetrafluoroethylene, and which is also called as the Gore-Tex or Draken, or biological materials, right? So blood vessels which have relatively smaller diameters, such as the cerebral and coronary arteries, biological substitutes are preferred, right? So smaller arteries, you generally do not use synthetic vessels. So tightly woven, crimped, non-supported Draken fabric prostheses have been very successful in thoracic aorta grafting. Knitted, crimped, non-supported Draken fabric for abdominal aortoiliac area, and knitted non-crimp supported Draken prosthesis for axillofemoral and femoropopliteal bypass. So these are the materials that are used for synthetic blood vessels made out of these materials are used for replacing such arteries. Now, biological grafting is basically taking a blood vessel from one part of the body and grafting it in another. Saphenous vein has been used for bypass, and that bypass of coronary artery or femoropopliteal arteries and coronary patches. So one of the major challenges that a surgeon faces while using these veins for grafting is to make the venous valve incompetent without damaging the veins, because you have the venous valves which help in pumping of the blood, right, from a different part of the body inside the heart. So if you are using a vein to replace an artery, you have to take away the venous properties of that artery, and that is a major challenge to do that without damaging veins. Heterografts have also been prepared from bovine or calf carotid arteries, but this have resulted in serious complications. Therefore, their use has been reduced to or reserved for people with with blood complications such as hemodialysis. If they have no other option, then you go for heterografts made up of bovine or calf carotid arteries. Otherwise, it is avoided if it can be. I think this is all I have to speak about vascular grafts. I hope you had a fruitful session learning about it with me. I shall see you again with more biomaterials. I hope you take care till then. Thank you.